Last stage, we split the agent into a controller that decides and an executor that acts. The model never touches your files. But that split is just one wall in a much bigger building. So here's the question. When you have hundreds of moving parts, what stops the whole thing from collapsing into spaghetti? Start with two words that decide everything: coupling and cohesion. Coupling is how much one piece needs to know about another. Cohesion is how much the stuff inside one piece actually belongs together. The goal never changes: low coupling between boxes, high cohesion inside each box, pieces that mind their own business and don't reach into each other's drawers. Now stack the boxes into layers. A harness has roughly four: the interaction layer where you type, the agent core where the loop lives, the tool layer that does work, and the state that remembers. The point of layering isn't tidiness for its own sake. It's that each layer only talks to the one next to it. Here's the rule that makes it powerful. The arrows point inward. The screen depends on the core. The core depends on nothing. Why? Because the core is the part you never want to rewrite. If the valuable thing depends on the disposable thing, you can't throw the disposable thing away. Flip the arrows and the core becomes permanent. So how does an inner layer use an outer one without depending on it? Ports and adapters. The core defines a port, a shaped hole that says I need something that can call a model. And the outside builds an adapter that fits the hole. The core never learns which model it got. It just knows the hole is filled. Let's make this concrete with the real thing. Here is the layered stack that nearly every coding agent is built on, drawn with the dependency arrows turned on. Top floor, the interaction layer. CLI, the IDE plugin, the SDK call. This is where a human or a program pokes the agent. It is the most replaceable part of the whole system, and that's by design. Next floor down, the agent core, the loop, the message queue, the turn logic. This is the crown jewels. Notice it has no arrow pointing up. It has never heard of the CLI. Below that, the tool layer. Read, write, search, run a command, call an MCP server. The core defines the port. Give me a tool I can run. And each tool is an adapter plugged into that port. New tool, new adapter, core untouched. Bottom, state. For Cloud Code, that's a single flat list of messages. No state machine, no swarm. Do the simple thing first. Every layer reads and writes state through the core, never directly. Now watch the magic. Continue. Dev took this exact core and shipped it three ways: VS Code, JetBrains, and a CLI, by writing only three new top floors. One core, three shells. That is dependency pointing inward, paying its rent. But a layered stack still mixes the pure decision making with the messy input-output. Next episode, we squeeze that even harder. Push every bit of I/O to the outer rim, keep the core spotless, and model the whole system as a stream of events. That's clean, hexagonal, and event-driven architecture.